Hello and welcome for the third lab tutorial as a part of EE542 Internet and Cloud Computing under Professor Yang Cho. This experiment is to create virtual machines using DETER lab to understand how to create nodes inside virtual machines, which could save a lot of space and also a lot of hardware resources. The goal of this tutorial is to understand what QEMU is, understand the container types that DETER can run, and also finally, once we have understood how to create virtual machines and virtual processes under DETER lab or under each physical node, the final step for us is to convert the given NS file into a VM version, a virtual machine version, which can run the nodes in QEMU. Virtual machines. Before we get to the tutorial, I want to briefly touch on virtual machines. So what is a virtual machine? Why do we need a virtual machine? So sometimes to have multiple systems or multiple processes running, you might have to virtualize them to save money on buying hardware. So virtual machine is an emulation of a computer system, which would give you the same functionality as a physical system, but just it's completely implemented in software. It would also rely on the processor to provide hypervisor controls, so that the guest operating system, which runs on the host, has direct access to the hardware. So there are two types of virtual machines. One is the system virtual machine, and the second one will be process virtual machines. In DETER lab, the virtual machine is first taken from the topology file. So the file, the .tcl file, would have the same compatibility with the NS2 syntax, and using that we would try to create a topology within containerized environments. So once we give the experiment topology, the container allocation system calls on the resource allocation in DETER and also the configuration system based on the settings that we give. So using that, physical resources are first allocated, and then once the physical resources are allocated, the code on the container.python is run on the virtual machines to create the nodes that we require. We've been talking about containers for a while, so I wanted to explain on the kind of containers that we can set up at DETER lab. So there are four different kinds of containers. One is the physical machine, which is the node itself. Like there are 200 computers on DETER, and then we could use one of them. So it's a one-to-one mapping. And then there's QEMU virtual machine, which emulates the hardware, and which can run up to 10 machines per physical machine. And then we have openvz containers. Each of them are like Linux, lightweight Linux kernels, and we can run 100 of them. And then VOS process. So it's just like a process within an operating system, but with an isolated stack, and we can run thousands of them. So using these, we can emulate or simulate a large number of nodes and large number of topologies in the network that we desire to design. Now, before we dive into the topology design and initial commands that we need to run, we need to learn what QEMU is. So QEMU stands for Quick Emulator, and it's the fastest processor emulator that is in market and which is also open source. The specialty about QEMU is that it runs independently on the host OS and doesn't depend on any of the virtualization techniques that the hardware TCL file. This is in fact similar to the NS syntax file that we've written for the previous lab tutorials. So the first one would be, of course, to write the source. And so we set up a new simulator. Then we need a center node. Now to create 9 other nodes which are connected to this center, we just run an iterative loop. It's a kind of a different syntax than in C. It's almost similar. Then, just like writing a shell script. incr would increment the I by 1 and then set. So this is my new node. Every time I write this, I create a new node. It's of type node, and ns duplex link with, of course, connecting it to the center, and then this node, the very same node that we created before, with 100 megabytes of bandwidth, 10 milliseconds of delay, and the queue which would drop the tail when it reaches full. This is as simple as it gets. We will run this in the DETER lab using a Python script which would containerize this. So final steps is to set up the routing protocol. As of now, let's keep it static, and the final command would be ns run. Let's save this thing and run it in DETER. My file to my file system in DETER, then let's make sure that we have it. Yeah, and then the way to run this experiment is to access the shared folders. I go to share, and then I type containers, and then there's a file called containerized, containerized.py, which basically containerizes my experiment. Then we mention the project folder, and then I would call it project name example, experiment name, this is my experiment, and of course we would be using the example.tcl file, and then we wait for the Python script to run and create the experiment for us, and it would spit out a URL which we can copy paste it in our browsers to access the file on DETER Labs web interface. There we go. Now, when we try to access the experiment on the web interface, it is surprising to see that we only see one node, which is not what we expected. What we would expect is to have one center with 9 nodes connected to it. And then even if you go to the visualization, it only shows one node. And even the NS file or the TCL file that we provided is completely missing here. This is not what we wrote. So what the Python script would actually do is create a P node, which is basically a container, and once we swap in the experiment, then the script in the container would run to create our topology that we desire. Once we swap in our experiment, we should be getting a topology which is shown in the figure, which is basically taken once we access a specific folder where we get the image. So the folder where we have to access the image would be inside the projects folder, and the experiment name, there's a visualization.png file. Once we download that in our system and try to open it, we get the actual implementation of the nodes. And also there's a host file inside the containers folder, which would give us the IP address, the nodes, and also all the details of the connections. Once we created the experiment and once it starts running in the node, what I mean to say is when we swap in, how do we verify that the nodes that we created is actually working? So the best way to do that is SSH into every node and then try pinging, of course, that would always work. So try pinging another node from one node, and then we would get a few parameters, which is one is time to live and also round trip time. So the round trip time should actually match what we specified in one of the configurations. DETER also supports start commands inside every container, just the way it supports in physical nodes. So we use the same command, and then one thing that we need to be careful is about the output indirection, the input output direction. So this would not work. And also all the logs that would come out of the started program would be stored in the start command.out would be the standard out, and the start command.error would be the standard error. Moving on to advanced usage, we would now want to create the same containers using the default QEMU container or the openvz containers. Now, also one thing to be kept in mind is that QEMU would support only 7 interfaces as of now. So let us we'll go back to the TCL file and re-edit our nodes to have only less than 7 systems. In this case, what I'm trying to achieve is by having one center and other 5 nodes surrounding it, as shown in the figure. To save recording time in the video, there's a standard process that we would follow. Every time we make a change in the TCL file or any configuration, we go back to the terminal, we SCP our new file into our users.datalab.net, and then also run the containerized.python file to create a new experiment for us. And then we would go back to the experiment, swap in, and try pinging. So we follow this standard process for everything going further. Or going on to mixed containers. So it's okay to have QEMU to support 7, but what do we do if we need more than that? So we can make different physical nodes, try different containerized configurations. So one can support the openvz, another one QEMU, and another one the actual physical node, which is shown in the text there in the screen. And also one of the experiments that we tried is by having a node 8 to be a physical node, and also the other nodes which is inside a container. With many options on virtualizing the nodes, we would want to do more. For example, to change the operating system of each node. So now DETER has various operating systems of that it can support. For example, CentOS, and there's Linux, and there's Windows. But for containerized experiments, Ubuntu is recommended, and by default Ubuntu 10.4 is selected. And if you want to change the version, we can do it. The first line of the screen says so. And the second one is to change the disk space, like a disk configuration. This is similar to setting up a new virtual machine using VMware Workstation or VMware Fusion. We get to set the number of processors, we get to set the number of memory of the RAM. We also get to set the hard disk space. It's similar to that. And there are more attributes that we can set using, we can set the same things in the TCL file by using the commands on the line number 3 and 4. And there's also some setting called prefer QEMU users. We can allow a specific set of users to access the QEMU by using the last command. We can specify the username and the experiment name and the project name. Then the container would provide access only to the users that we specify here in the file. The more interesting part about this experiment is the packing factor. So we now know how to add more nodes. We now know how to add more systems inside different containers and different types of containers. What we would now want to do is how many nodes to be set on a physical machine, right? We need more control over the program. We need more control over our topology. So a packing factor would decide how many virtual nodes to be put on each physical machine. So the syntax for that is 2 hyphens and packing when we run the script. It's as shown in the screen there. And if we use packing factor 2, that means every node has only 2 systems or 2 routers or 2 links involved, and then everything still comes back to the center. Now there are many different configurations. We'll run through them quickly. The next one would be to add as many nodes as possible. For example, in this, we have set 3 nodes, 3 centers, and then each center would have 20 different nodes. So this is the code, this is the TCL format that we have to specify. So inside a for loop of 3, I set another for loop of 20. So that means 3 into 20 is a total of 60 nodes. And once we run this script and then wait for it to generate, and then we go back to DETER and then swap in to this experiment, and we download the visualization PNG as mentioned earlier, we would get this. So this has created a center with 3 LANs and each LAN having 20 different nodes. There are various settings, and the next one would be to set different kinds. For example, each LAN having different groups, right? So 0, 1, 120, 2, 10, and 3 and 5. And then once we run this, we would get something as shown in the figure below. And the next one would be to play around with the pass packing. So nodes only. So this is a setting which would prioritize the nodes over other things. And more on packing factor, these are single pass, per pass, and it's a matrix on how we can play around with the parameters. So the final thing that we would need is the microcloud setting. So what this does is, depending on the format that we specify, it would group nodes into 2s, 3s, and 4s on what we mention in the TCL file or what we write through the script. Coming to the last portion of this tutorial, this is the way that we have modified the NS file to VM specifications to make them run on QEMU. What we have done is changed the containers to have node type as QEMU. We have removed the operating systems that were given as a part of the previous file, and we still keep the links and the LANs as is, and we change the protocol to manual, and then we still go back using this, go back to the terminal using the same file. We SCP it to our DETER interface, and then run the experiment by using the Python tutorial, the Python script, and then use the link to swap in the experiment and try pinging into different nodes, and finally download the visualization file, and this is what we get. It uses 2 LANs and also the routers, and also sets up all the nodes that we require. This would complete the Lab 3 tutorial. Thank you for listening, and please do provide all the feedback so that it can help me create better videos in the future. Thank you very much.